Hey viewers, welcome back to our channel. Hope you're doing extremely well. So today we are going to discuss another interesting interview question, which is frequently asked in the interviews. That question of the trees, that is nothing but delete node and return forest. So there might be possibility that you might hear about this question, and there is a fear in your mind about this question. But today, what we are going to do, we will try to understand this question in very easy language, and we will try to solve it. Okay. So without wasting time, let's move on to the question. So what we are provided in this question, at first let's try to figure it out. So I'm saying that in this question we are provided with a binary tree. So let me create one of the binary tree, that is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 and 19. Okay, so here you can see we are provided the binary tree, and along with the binary tree we are provided with one of the vector or array list. We can see having some of the nodes. So let me write some of the make an array list. Okay, so at first I'm taking it as 5, another I'm taking it as 9, and the last I'm taking it as 15. Okay, so I'm taking these three nodes in my array list or a vector. So what these nodes actually signifies, okay, what these node actually signifies, these node actually tells us that we need to delete all these three nodes. Means all those nodes which are present in a vector array list, which are provided with us along with this binary, we need to delete all these nodes from this binary. So means we need to delete this 5 from this binary, this 9 from this binary, and this 15 from this binary. Okay, this is the first task which we need to do in this question. Let's figure out the second task which we need to do. And after deleting this binary, after deleting this 5 9 and 15, so let me delete this 5 9 and 15. So after deleting this 5 9 and 15, our tree will be look like this. This 9 will be removed from something from here, 15, and this 15 will be removed something from here. Okay, and after deleting our these nodes, our tree will look like this. What we need to do is this. Here you can see that this actually is nothing but one of the binary. This is one of the binary, this is the another binary, this is one of the binary, and this is one of the binary. Why these are the binary? Just because we have deleted some nodes, and after deleting the nodes this becomes the different binary. Okay, what we need to do, we in this question we need to create a new array list or a vector, and we need to store these binaries root. Okay, we need to store these binary roots. Here you can see the root of this binary, this particular binary is nothing but this 16. The root of this binary is nothing but the root node, that is the 1. Similarly, for this binary the root is 10, and for this binary the root is 11. So what we need to do, we need to store them in some of the data set, and we need to return it. So this is what we need to done in this question. So I hope you get the understanding of this question. If you don't get it, please watch it again. And if you got the question problem statement of this question, then it's my request, please pause this video right now and try to solve it by yourself. And obviously we are discussing the solution after all. So uh, let me recreate it. Yeah, it was 15. Okay, now let's try to understand the discussion approach. Okay, so the first thing is that we need to delete some nodes of the binary, and we already know how to delete it, but here we need to perform one more task along with the deletion, that is nothing but storing the roots of the children's. Okay, so you might be thinking that in which order we need to iterate over the binary, whether we need to do it in the in order or pre-order or the post order. Okay, so let's try to figure it out. Okay, so what I'm going to do at first is I'm going to store this data in a set, in a hash set, or there is another data structure for the C++ programmers. Okay, so I'm going to store it in a set. Why I'm going to store it in a set? Uh, just because in a hash set, okay, in a hash set we can access any of the element in order of one time complexity. I don't want to spend any of the time in accessing any of this data structure. Okay, that's why I'm going to use a set. I'll just store these values into this set. So now try to iterate over the binary. Okay, I don't know which iteration I'm doing, which traversal I'm doing. I'm just going to iterate over the binary. Okay, So at first I get this 1. Now what I will do, I will check whether this 1 is actually present in this set which I have created right now or not. Here I come to know that this 1 is not present. What I'll do, I'll move forward. I will reach I will reach to this 2. Again I will ask whether this 2 is present in a set or not. Here you can see that this 2 is not present. Let's move forward. We reach to this 4. Whether this 4 is actually present in our set or not. No, this 4 is also not present. Let's move forward. We reach to this 8. We ask the same question. We get the answer no. But the moment we reach to this 9, here we come to know that yes, this 9 is actually present in a binary. In the set that we have created. Okay. Now, what was my first task? Actually the first task was of the deletion of the node. So do I need to delete it right now? Can I delete it right now? You might be thinking that yes, it is yes, as it is required to delete the node in a question, so why not to delete it? But I'll say that I'm not going to delete it right now. I will delete it during the backtracking or the a little bit later. Okay, why? Why I will do it little bit later? Let's try to figure it out. Yeah, here I come to know that I need to delete this 9, but I am going to store this information in any of the variable, or I'm going to store this information in my mind. Okay, let's move forward. I reach to this 16. I come to know that I don't need to delete this 16. Similarly, no need to delete this 17, and similarly no need to delete this 19. The moment we start backtracking, we reach to this 17, we reach to this 16, we reach to the 9. Okay, here I come to the 9 again. Okay, and as per our requirement, we need to delete this 9. Now can I say that I can easily delete this 9? Means there is no such stress or pressure on this 9 that whether is there any future node or whether is there any children node of the 9 which actually need to get deleted but which will not be deleted due to the deletion of this 9. There may possibility you are not getting it. Okay, let me try to explain it in a simple word. Okay, when we delete it in a pre-order, okay, means the moment I get this 9 at the first attempt, the moment if I will delete it, there may possibility that I will lose the future information. Okay, I will lose the remaining information which is actually attached to this 9. Okay, if I delete this, this link will get break. Okay, and the possibility of accessing the 16 will become less. Either I need to save it somewhere else, or either I need to do something else. Okay, so if I try to solve this 16, try to store this 16 in some any of the other data structure, then definitely my work will get increased and it will become more hectic. Okay, it will become more hectic. But now what I'm going to do is that I'm making an assumption that yeah, I get a node, I encounter a node which I need to delete, but I'm going to explore its children's at first, and the moment I start backtracking, I will delete it in a post order. So here you can see that in this question we are going to work in a post order. Why we are going to work in a post order? Because if we delete a node in a pre-order, if we work in this question in a pre-order and if we delete it, there may be possibility our work will get increased out, or we need to do some more work to handle the children's of that deleted node. Okay, so I'm assuming that we will work in a post order, means the moment we start backtracking, we will delete it, because in this moment I have a faith, or I can trust only this 9 that its children's, if any of its children's which need to get deleted is already deleted up and there is an updated 9. Okay, means its children is already updated. I can easily update this 9. So what I'll do, I will delete this 9 now. So yeah, this 9 will get easily deleted without any stress. Now let's again backtrack. We reach to this 2. Now moving forward, I make a call to this 5 where I will ask the same question whether I need to delete this 5 or not. Yeah, I need to delete this 5. Okay, so can I delete it right now? No, if I delete it, this 5 node right now, the information of 10 and 11 will get lost. Okay, the information of 10 and 11 will get lost, and then with possibility I need to store it somewhere else to make a traversal on them. But I don't want to increase my work, so what I'll do, I will delete a node in a post order. So uh, let explore its children. I reach to this turn, I will ask the same question for it, and here I come to know that no need to delete this turn. Moving the 11, no need to delete this 11. Let's backtrack. Reach to this 5. Okay, now during the backtracking time, what we'll do, we just delete that particular node, and here I'm going to delete it, and we deleted successfully. Now again let's backtrack. We reach to this 1. Now make a call to this 3. We reach to this 3. Again asking the same question to the 6. No need to delete 6, 12, 13, 7, 14 and 15. We reach to this 15. Okay, now here we need to delete this 15. Do I need to ask, do I need to move forward? Just because this is a last node, this is a children node, means it don't have any of the children, it don't have any of the node which I need to explore. Okay, so what I'll do, the moment I encounter it, or the moment, as there is no such backtracking, so I can delete it easily. Okay, so I just delete it. Now you can see that here I have some of the binary. This is one of the binary, this is one of the binary, this is one of the binary, this is also one of the binary. Okay, this is one of the binary. So according to my question, what I need to do, I just need to return their root children. So the root of this binary, that is nothing but 1. The root of this binary, that is nothing but 10. The root of this is 11 and the root of this is 16. I just need to return this data. I hope you get the understanding part of this question. So now what we are going to do, we are going to move on to the Pepcoding portal, and now we are going to write the code there. So this is the Pepcoding portal, and now what we are going to do, here we are provided with a delete node function. We need to complete it. Okay, so let's complete it. Here are two parameters, that is the root and the vector of a map, and within this vector word, it contains all the integer value of those node value which we need to delete from our tree. Okay, so let me create something at first. What I will create something as per my requirement, that is I'm going to create an unordered map. Ordered, unordered set, actually, not the map, unordered set, I just forgot it. Unordered set, and with the name set. And now what I'm going to do, I'm just going to add that value, that value of those nodes which I need to delete into this set. So for auto L into this set, or from this map actually, into this set dot insert element. So this is inserted. Now what I'm going to do, I'm going to create a vector, tree node star answer, and one more thing, that is a helper function. What this vector consists of, it contains my original value, it contains my answer actually, as its name is answer. Okay, and this helper function we are going to create it soon, but it will take some parameter, that is the root set and answer. These three parameters it will take. Now let me create this function. Okay, tree node, it will be of tree node type, tree node star and helper. Tree node star root. Okay, the other thing will be unordered map, unordered set actually, unordered set of int, unordered set of int of name set. Similarly, vector tree node reference answer. So what will be our first thing? First thing is handling the base condition, that is if we encounter the null, it is null, we will return nothing but null. Now as per our requirement, what we discussed earlier, we will discuss that we will work in the post order, means our all the handling of the task we'll do it in the post order. At first we'll make the course, so root left, so here I'm making the course toward the left and the right, root left, similarly root right, root left will be nothing but helper, root left set and answer, helper, root right, set and answer. Okay. Okay, so moving forward, I'm assuming that I have reached out to any of the node which on which I need to work on. Now let's discuss our condition on which we need to work. The first condition was deleting the nodes. So before deleting it, I need to check whether this node is actually need to get deleted or not. So I'm right set.find root well, and if this is not equals to set.end. If yes, I need to delete it. What I'll do, I'll check whether if that root left exists. If it exists, I will add it to my answer, just because it is now a new subtree which I need to return it out. So answer.add, answer.pushback actually, answer.pushback root left. Similarly, if root right is not equals to null, I just return answer.pushback root right. Okay, so here in this case I just return null. Why I'm returning null? Because here I'm updating the link. Here I'm updating the link and deleting out that node, and okay, otherwise I just need to return root. So one more thing which I need to handle here is checking for the root condition. Okay, because we also need to return the need to insert the root into our answer array, and before inserting it we need to check whether in the map function, sorry, whether in the map array the root value is also included or not. So I just need to check if set.find do I really need to delete the well? Okay, such a thing happen. What I'll do, pushback pushback root, and at last just return the root. So that's all for the code. Now let's try to run it, and if we encounter the error we will figure it out. So here we get an error of set.find root well equals to set.find. So at line number 58, so let's check it. Okay, set.find root well equals to, okay, note the find. Here I need to write the end. I just it was just a mistake. Really very sorry for that. So we get the another error, and it is just because we are returning root tree node star. So let me check it here again. Tree node star helper. Now obviously we can return tree node helper is a okay. The error is at this line. I'm really very sorry. I'm returning the node, but no, I don't need to return the node. I just need to return this answer. So let's finish. And yeah, here our code is accepted. That's all for this video. That's all for this explanation. I hope the fear of this question is uh, now there is no more fear in your mind about this question. Okay, so let's end this video, and let's meet in the next video. That's all for this video. Okay, if you like the content of this video, don't forget to hit the like button.